Hey everybody, what's going on? We got cool stuff today. We're going to do the strategy pattern. And first, if you've been watching all these videos, we've kind of done the strategy pattern before, but I haven't made an official video. I think when we did composition, we basically did a strategy pattern. So I thought we'll do an official one just to cover it. I think it's essential to me, probably the three most useful patterns: factories, the facade, and the strategy pattern. Strategy slash state, because they're kind of the same but different. Maybe we'll do state next week. So strategy. Let's get the book out. Whoa! I had my phone. Did you see that? My phone just kind of. Anyway. All right. Here's the classic book on design patterns, and let's see what they have to say on the strategy pattern. The intent here is to define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from the clients that use it. So we're going to get into that. This is an amazingly useful pattern. I always say it's amazing how much better you can make your code with simple factories and a strategy pattern. There's a lot of patterns. I mean, there's lots of design patterns, some you won't use very often, but I feel like I end up with some variation of strategy and factory almost daily in my code. So let's get over to IntelliJ. So people ask sometimes, like, hey, what editor are you using? I use, this is IntelliJ with the Illuminated Cloud Salesforce plugin. If you're using Visual Studio Code, works just as well. Follow along. You have to pay for Illuminated Cloud. Visual Studio Code is free, of course, if you don't value your time. And I can't, right? Visual Studio Code is fine. I just think Illuminated Cloud is the better tool and worth a couple bucks out of my pocket. So let's go real quick. So I wanted to show, we did a couple things ahead of time. So what I wanted for this one was to demonstrate how the strategy pattern would work, and really I think where it really shines when you have some front end code. So we're back, if you remember back when we did some of our universal pizza stuff, right? So we have this, we're starting this payment application, right? And a user, right? So they're going to say, like, do I want, debit card, credit card, right? PayPal, right? They have these three options. And they're going to submit a payment. Okay. And each of these payment types requires, say, a different algorithm, different processing, different web callouts, etc. And you as the developer, right, you have no way of knowing which one to implement. You won't know until runtime because you have no way of knowing what the user is going to select. And that's really what the strategy pattern is about, is it's going to let us encapsulate that family of algorithms, right? Our payment algorithms, our payment processing algorithms, right? Our debit card, our credit card, our PayPal. We're going to encapsulate those. And then we can call them, we can swap them out interchangeably at runtime. And our front end here, right, our Lightning Web Component, like they should never know, right? So we can make changes in our back end completely independently of our front end, right? So, and that's the ideal. That's what we want. So little Lightning Web Component, you can see the stuff. I put a couple things in console.log to make it simple, but we won't really come. So right now, everything is returning a true by default. All right, so we have our Lightning Web Component. We'll just real quickly, we'll walk through, let's walk through the code in there, payment.js. Okay, so you can just see, right, we're importing the controller method, right, and on submit, we're going to send this payment. We're going to pass the current payment option from that drop down you saw. We're going to pass that to the controller. Very simple controller, just going to take the string, right? Debit card, credit card, etc. Now, what we need to do, so I guess the first thing we need is a shopping cart, right? So let's create a shopping cart class. I thought I had a hotkey that I'd set up to create classes, but I guess not. Apex class. All right, let's call this our shopping cart. We're going to add that to get. Yes. Okay. And in our payment strategy, in our shopping cart class, we're gonna just start off with composition, right? And we are going to give it a property of iPayment. And so this is, kind of one of the nice things you can do with Illuminated Cloud is, right, I can because it's like that class doesn't actually exist yet, I can just go ahead and create that from here by hitting Alt-Shift-Enter. All right, and yes, and we're actually going to make that's not actually a class. We're going to say public interface, and that's a lowercase I. Public interface iPayment, and we're going to give it one method. That's going to return a Boolean. Submit payment. We don't need those curly braces there because we're in an interface. And that is all we need for that right now. Okay, so we have an interface. We have our superclass, and we have our shopping cart, right? That is going to use composition to determine. So we're gonna put different algorithms in there. Here, let's open up our get a little UML here ahead of time. Maybe we should have led with this. Let's zoom up. All right, so we're gonna have our Lightning Web Component. Lightning Web Component is going to use our payment controller. All right, submit payment method. So really, the payment controller is going to end up creating a shopping cart class, and the shopping cart class is going to contain an iPayment interface. And then we are going to have 3 concrete implementations of the iPayment, right? We're going to have a credit card, debit card, and a PayPal. And because they are going to implement iPayment, they all have to have the submit payment method. And, you know, if this was real development, right, we would have complicated stuff in there. But, you know, we're not, because it's YouTube. We're going to have like a debug statement in there. But you'll get the idea, right? So let's close that out, and you can see the dependencies, right? We have, and this is what we want. So the controller, but we can change, also we can swap any of these out, right? And our front end is never going to know. Our payment controller, never going to know. Heck, our shopping cart is never really going to know, right? If we just, you know, as long as they implement iPayment and we're using composition, you know, if we want to take, I don't know, you know, Bitcoin or Dogecoin. Maybe we take pizza and Dogecoin, right? You could tip me in Dogecoin if you like this video. Maybe it'll be worth something someday. We can just swap that right in because this is what we're going to do. We're going to swap out these algorithms. So let's create a couple. Let's create these concrete iPayment implementations. Apex class. We're going to do debit card. Let's put this to don't ask again so you guys don't have to keep seeing that pop up. Implements iPayment. And submit payment. And we are, okay, we'll put a debug statement and then we're just going to have them all return true for right now. We'll call them the debit algo. All right. Now let's do a credit card. So credit card also needs to implement iPayment. And Control I, submit payment. See there again. Beautiful thing about IntelliJ Illuminated Cloud, handles all that boilerplate for me. Because it knows I'm implementing iPayment, I just have to Control I. It takes care of all of that for me. And we'll do system.debug in the credit card algo. All right. And one last one. Well, we need PayPal, right? Apex class. Implements iPayment. Debug, and we are going to say we are in the PayPal algo. And you know what? We're going to have this one return false. And that'll just kind of be our check in the end. If you remember those alert statements I had get thrown up in the Lightning Web Component. So we should know, just as a kind of a final proof, right, that when we submit a PayPal payment, we should get a false back. Shift F9. Let's push this all up to the, before I get too far ahead of myself and compiling gets weird, we'll push that up to our scratch org. And I'll have a sip of delicious coffee. All right, there we go. Everything is in the scratch org. So let's think. Let's go back to our shopping cart. All right, so let's think about what we have next. So we need some way to instantiate. We've got our concrete, we have our interface, we've got our superclass, which is our interface. We have our concrete implementations of the iPayment interface, but we need a way to get these into the shopping cart. So let's do this. You know what we're going to do is we're going to create a little factory, and we are going to use dependency injection in the constructor. So first, let's create a factory. We're going to say it's our payment strategy factory. All right. This should work. Static iPayment. And now I want to call it right. That's the really powerful thing here. And that's what polymorphism is all about. Is we're going to have this factory, and it's remember, it's returning that superclass of iPayment. And this is where your code gets really powerful, in my opinion. This concept took me a long time to understand. But instead of returning a debit card, instead of returning a PayPal, I can return anything that implements iPayment, right? And so this starts to make your code really powerful, really flexible, once this concept makes sense to you. And I hope these videos help, because it took an embarrassingly long time for me to start to understand this stuff. So let's say we're just going to say get strategy, and we'll just pass in a string strategy name. And we'll do a switch statement, switch on strategy name. And we'll say when PayPal, can't quite remember. You know what? We should take a look, because fundamentally this is going to come down to the values that I put. Okay. It's going to come down to these values I put into the Lightning Web Component, right? So I just wanted to check those real quick, save myself a little bit of time here. Maybe some embarrassing typos later. Okay, so everything's lowercase in the LWC. Good enough for now. Return new. What was that? Return new PayPal. Right? Say when debit card. I am doing some. Oh, okay. I got some weird stuff going on. I'm trying to figure out what. All those red squigglies were starting to kind of freak me out. Let's debit card. Return debit card. All right. I should be able to clean that up a little bit. We've got some crazy spacing going on there for my last mistake. And then we'll do when credit card. Return new to give it a return. Not a 2 L's and null, right? All right. Clean that space up. Switch on. Strategy name. I'm going to do that just because that should work, right? That makes me feel a little bit better. Typo more debit card. That way, maybe later on if I change something. So let's see. Let's try to compile that. All right. So now we have a little factory. Okay. And back to our shopping cart, right? All right. So now we got to set up our constructor. Public shopping cart. And we need to pass in a payment. And we're going to say this dot payment strategy equals payment. All right. So that should work. So I'm going to compile this. And then I'm going to open up Anonymous Apex just to test something real quick. Make sure it's working the way I think it will. Hey, we've got FizzBuzz in there from something I set up from another video. Okay, we are on the right one. So let's say we need shopping cart equals new. I'm going to give us a little more space here real quick. New shopping cart. And if we do our strategy, credit card, let's just see what, make sure, let's see what we have in there. We'll do system.debug, cart dot. Did I not make, let's go back to our shopping cart, make it public. For right now, we'll just make that public, good enough. Just see what we got in there. All right, debug only. Let's run that. Variable is not visible. Shopping cart dot payment strategy. Yeah, because I made it visible, but I didn't compile it. But what we really need to do anyway, I guess, is public Boolean. And then at the end of the day, we've got to be able to submit a payment. Payment. And we're going to say, so now, remember what we're going to do is we're going to delegate. The shopping cart is not really submitting the payment, right? The payment strategy class is doing it. So this is delegation. So we're going to say this dot payment strategy dot submit payment, right? So again, our shopping cart doesn't know either. Shopping cart is completely ignorant, right? Do I have a debit card? Do I have a credit card? Do I have PayPal? Do I have Dogecoin, right? All I know is I require a class that implements iPayment. That's all shopping cart cares about, is that it has that thing. If it has that thing, it can then do a submit payment, because anything that has, let's see, that's not working. So do we payment strategy dot submit payment? They all return Booleans. But can we not return it from right there? There we can. Sometimes I get red squigglies, maybe because it just takes a little long to index stuff, and I think I made a mistake when I really didn't. But Not, I don't say that like I don't make mistakes when I code, because I make a lot. But I don't think I did this time. So this is a nice way also to just, I'm going to point this out when you're refactoring to inline that. You, instead of, Boolean result equals, this dot payment strategy dot submit payment and return result, right? You could just inline, you should be able to just inline the whole thing, one line it like that, and just make your code a little neater. That's a couple less lines that you have to maintain, which is always good. The less code you write, the better off you are. All right, so I think we compiled this, but just to double check, let's hit it again. We'll watch pushing or change metadata. All right, back to our anonymous Apex. Let's see if that works from there. Debug, and we're going to do one last. Debug part.submit payment, right? All right, perfect. We're in the credit card algo, and we got a true. So that is working. So now the last thing we should have to really do to wire this all together is, so we know our shopping cart is working. We've got our superclass. We've got our concrete payment types. Is we go back to our controller. And we want our controllers really to be logicless, right? We should not have business logic in there. So what we are going to do is, we'll say, let's see, what do we need? We'll just say cart new shopping cart. And we'll say then it has a payment strategy factory. Payment type. All right. Oh, we got a get strategy. There we go. And we're going to say return cart dot submit payment. That's, and obviously, yeah, right, for real, we'd have, a try catch or a handled exception in here, but I'm looking at my clock, we're already at 23 minutes, so I want to wrap this up. And so now, if this works, let's go to, let's go back to, I'm just going to refresh the page real quick. Don't think I would need to. We also have our developer console, so let's refresh that. I'm just so we can have stuff in the debug logs here too. We are going to debug, clear the checkpoints results panel. All righty, back to our demo app. So let's submit a debit card. True. All right, let's see what we have in our debug logs. If this is all working, calling the debit, boom, it worked, right? I'm surprised myself that this is working the first time when I'm doing this live for a YouTube video. Let's see if we can go 2 for 3. All right, debit card worked. Credit card, submit payment. True. Again, we got what we expected. Debug only in the credit card. How about that? 2 for 2. Last one. This is the proof that it's all really working, right? This should return a false. Let's see what we get. False. Yes, it worked. All right. So let's, no tricks up my sleeve. Let's open up our logs. All right, you got it. That is the strategy pattern. That's really all there is to it. We did some dependency injection, in the constructor injection. So let's take a look again real quick at our UML. And where did I put that file? We'll go to strategy UML. And I'm going to throw this out there. If anybody is wondering, and I think there's a free plugin for Visual Studio Code if that's your editor of choice. This is the Plant UML plugin, which is free. It's a great tool. I use it every day at work. I love it for these videos. Doing class diagrams, state diagrams, sequence diagrams will also help you think about your code and how it's all going to work together. So I really recommend you get into the habit of that. But so if we think about separation of concerns in our layers, all right, so we have our presentation layer, our Lightning Web component, and our controller, all right? Controls for the LWC, presentation layer. And that's going to make a call really to our service layer here, right? The shopping cart. And if you remember, so they're using the shopping cart. Shopping cart uses composition, right? So when we talk about composition, it's a class made up of classes. The shopping cart has a property of iPayment, right? And I should actually put that in there. But if you remember, let's go back to our, just to stress that enough. This is, I mean, when you're first starting off, I think you have this idea that your class properties can only be primitives, strings, booleans, integers, whatever. No, your class properties can be just about anything you can think of. If you can code it, they can be a property. So now we have a class, and one of its properties is another class, or, you know, a superclass of iPayment. Right? And iPayment, right, it's an interface. We can't instantiate an interface directly. We can only instantiate classes that implement that interface. So we have these three concrete implementations of iPayment: debit card, credit card, and PayPal. And then, right, we just put a little factory in. We pass that factory into the constructor injection. And that's it. You've got a strategy pattern. You've got a factory. And again, I think you'll be amazed how far you can take your code, how much better you can write it with a couple of these really simple patterns that, again, like, they're not like, I don't know, like abstract factories or decorators that I think really chain of control, right? That I still have to go look up in the book every time if I need to implement it, because they're hard to follow, in my opinion. So that's it. I hope this was useful. Thanks for watching, and I'll see you in the next video. Take care, everybody. Keep getting better. Keep practicing every day, and let me know in the comments what you thought.